everybody. This is a lab we would normally do in the computer lab, and it uses an older software called Java, which does not work on iPad, and it wouldn't work on your newer updated computers. You are welcome to try it on your home computer if you would have a better time working with the controls of this model. That's certainly better than watching a video, but I don't think too many people's computers will be able to do this. I'm using a at least 10-year-old computer that hasn't been updated in a while. So this greenhouse gas lab lets us model or mimic some of the things going on with the atmosphere and with the earth. So it's a little bit earth science physics type stuff, but not terribly difficult, of course. All right, so you can follow along with the handout and pause or go back if you need to. So taking a look at this here, we see symbols over on the top right. Yellow represents the visible light wavelength coming from the sun to the earth. Red dots represent heat energy, infrared photons, and the infrared would be warmth or heat that you would feel. Notice the direction of these photons. It seems like only yellow is headed downwards, and it seems like only red is headed upwards. And that might not make much sense to you because you think the heat comes from the sun as well as the light energy. So here's what's going on. Even though the sun is so hot, it is emitting UV radiation, X-ray radiation, heat radiation, light radiation. The heat gets very dispersed on its way through the atmosphere. Not much of the sun's heat energy directly gets to us. What's happening is the light photons hit the earth, hit rocks, dirt, water, cars, rooftops, trees, and it changes the wavelength of that energy from the visible light spectrum to the infrared or the heat or the warmth feeling or spectrum. So most heat we feel is not coming from up to down. It's the radiation of that sunlight energy back at us. So that's something a lot of people don't realize before they take this type of class or study this sort of thing. Notice the thermometer down here on the left. Right now we have an average temperature of -1, -2 degrees Fahrenheit. I'm not worried about the Kelvin. This is the Earth with no greenhouse effect. And then as a metaphor, we're going to add glass panes to this greenhouse effect. So now I have added the first glass pane. Watch and see what's happening with the different photons, what can pass through the glass, what can't. Also take a look on the bottom left. Now our temperature is 71 degrees Fahrenheit. I'm going to change up to 2 glass panes. Give it a second to see what's our new temperature. New temperature is 88, 89, 90, 98, 100 degrees Fahrenheit, 104, still rising. And then if I add a third layer of glass, this is like being in a literal greenhouse where the sun can get in but the heat can't escape. Or you can think of it like a parked car in a parking lot where the sun is coming in, but the heat can't escape. Even if it's only 30 degrees out in December, if it happens to be sunny, the light rays coming into your car bounce off the seats, the dashboard, and changes to the infrared wavelength. And that heat then stays in your car if all the windows are closed. So that's our first tab, and that should get us through number 4. So you can stop and rewind if you need to answer 1 through 4 on your handout. I'm going to move on to number 5. Here's a little bit more about the physics or the chemistry of what's going on. We call these packets of energy infrared for heat or visible light for the actual sunshine, the light coming through, which you can think of as different colors. And I'm going to bombard molecules with either the heat energy or the light energy. So let me put all the molecules in here. This first one you see is methane, CH4. The next one we see is carbon dioxide, CO2, water, H2O, N2, the majority gas of the atmosphere, and O2, the second most common of the atmosphere. So I'm going to put all of those here, and then I'm going to bombard them with energy, and then you can take a look, maybe I'll make a little less, you can take a look and see what happens to these molecules when they get hit with energy. So here we go with the heat, or the infrared. What you want to look at is what happens to the molecules when they get hit with the red packets of energy or heat. Now I'm going to take a look at the visible light spectrum. Same thing. Now I have visible light, the yellow packets of energy coming from the sun to the molecules. I don't see any of them vibrate or resonate. So I'm going to go back to the infrared, because that does cause a change in the molecules, and it's called resonate. And I'll just do one at a time so you can write down which molecules actually resonate when they're hit with infrared. None of them resonate with the visible light, only this infrared. And it may not resonate every time. Certain molecules are more potent greenhouse gases than others, based on their molecular arrangement. Okay, so that one is methane, CH4. Moving down the list, here's carbon dioxide. Here's water. Here's nitrogen gas, our basic N2, non-reactive, also not resonating. Here's O2, about 21% in our atmosphere, not resonating. So that's what I wanted to show you with this tab of the simulation, and that should get you through number 6. And now I'll move on from set to number 7 through the rest. And that's a bigger picture sort of situation here. And let me show you some things that are changeable on this part of the simulation. On the top right, we have the key that yellow is for the sunlight and red is for the heat or infrared. I can change the greenhouse gas concentration. I can change what time of Earth history we're looking at. Are we going to look at the Ice Age? Are we going to look at 1750? Or are we going to look at today? And they have filled in the greenhouse gas concentrations for us. I can also change the number of clouds if I want to. And I can always check the temperature here on the bottom left. So let's see, the first question says, what effect do clouds have on the visible light photons coming from the sun? What effect do clouds describe this effect of cooling or warming? So I'll just leave it at today. Average temperature of 58, 57 degrees. I'm going to add one. Oh, come on. Give me some clouds here. Adjustable might be what I need. Let me add some clouds here. Starting out at 61 degrees Fahrenheit. That's weird. My clouds worked yesterday. Let's try this. You might have to skip this one about the clouds. That's weird. I'll try it again in a bit to add some clouds to this situation. All right, we'll move on to, we'll skip 7 and 8 about the clouds, but generally clouds block light, as you know, And then clouds can also reflect some of the infrared back to Earth, kind of like a blanket. So clouds kind of have a zero net effect, but that's a part of research that's happening all the time right now to see how much clouds change the climate, change the average temperature of the Earth. Okay, so we'll go down to number 9. You have to fill out a table comparing Ice Age 1750 and today. We want the average temperature of each time period and the concentration of the gases. So I'm right now on the Ice Age, and in the Ice Age, water is unknown, question mark. CO2 is 180 parts per million. The methane is 0.38 parts per million. And the gas called nitrous oxide, N2O, is 0.215 parts per million. And looking at the average temperature in the Ice Age, we're at about 31, 32 degrees Fahrenheit. Let's see if I can add any clouds. No, it won't really let me keep any clouds up there for long. Okay, moving on to 1750, so you can fill in your data table. 1750, we have some changes in agriculture, we have some changes in population, we have some changes in industrialization. We're just getting to that point. Now, I will read you the concentrations to put in your data table. Water at 70% relative humidity, carbon dioxide at 280 parts per million, CH4, methane, at 0.7 parts per million, nitrous oxide, N2O, at 0.27 parts per million. Average temperature, look over here, bottom left, 59 degrees Fahrenheit. And now we'll go to their pre-made settings for today. In the pre-made settings for today, water's at 70%, carbon dioxide 388 parts per million, although if we look at NASA's website, we're well over 400 now. We have methane at 1.8 and nitrous at 0.317. Average temperature looks to be about 60 degrees Fahrenheit. So you should be filling in that chart. What's the relationship between the equilibrium temperature and the greenhouse gas concentrations? That's for you to look at your chart and think about yourself. I hope this was somewhat okay as a replacement for a school activity. Feel free to rewind and go back for whatever you need. You can upload this to On Campus. If you could do it in a blue ink or something other than black, that's helpful for me on the grading side, since On Campus only gives me a black pen. And I hope you have a good day and find a quiet place to read modules 62 and 63.